What's up, math scholars and math haters? This is Mr. W. We are going to finish up the third and last lesson on binomial probability and on all of probability in discrete math. We have a factory that's testing their machine that makes, bottles. I think I was thirsty when I wrote this question. The probability of any bottle being defective is 0.125 or 1/8. You will test 9 bottles and you'll know that the machine is working if less than 3 are defective. All right, so let's start with the wording of this. Less than 3. Now, for at least, we could start, or since it was at least 7 questions, we started at 7 and went from there. But less than does not include the number that is mentioned right after that phrase. So less than 3 means that it's anything from 2 down. All right, so let's go ahead and fill in some of this information. We're testing 9 bottles. The probability of any bottle being defective is 0.125. The probability of any bottle not being defective would be 0.875. I will write in my formula shell here. So filling in the information we already know, this is 9, choose whatever we're testing. And then 0.125 is in that set of parentheses, 0.875 is there. What's changing, again, are the number of successes and the number of failures. And once again, I wrote these in the same color that I've used to talk about successes in the other binomial probability videos we've done. And if there's 2 successes out of 9 bottles, there's 7 failures. 1 success means 8 failures, and no successes means 9 failures. So let's go ahead and do these. Let's go from the top down this time. If this is 9, choose 2, 0.125 to the second, and 0.875 to the 7th. And go ahead and break out my calculator and do this formula. 9, choose 2. Times 0.125 to the second times 0.875 to the 7th gives me 0.22089, okay? Or 0.2209. Next, we'll tackle 1 success and 8 failures. That's 9, choose 1. That's to the 1st power, and that's to the 8th power. And we use the formula once again. 9, choose 1 times 0.125 raised to the 1st times 0.875 raised to the 8th, and that's 0.3866. And finally, for no defective bottles and all working correctly, that's 9, choose 0, 0 power, exponent of 9. And once again, I'll go ahead and break out those tricks that I'll use to make some of these problems easier. When we see either 0 successes or all successes, 9, choose 0, that's just 1. This to the 0, anything to the 0 except 0, is 1, so this is 1 times all of this. And if I want to type this in my calculator, all I need to do is do 0.875 to the 9th power, and it gets me 0.3007. And once again, I just need to add these individual probabilities together. So 0.3007 plus 0.3866 plus 0.2209 is 0.9082. So there's about, if the probability of any one bottle being defective is 0.125 and we're testing 9 bottles, there's about a 91% chance that you will get less than 3 defective bottles. All right, so those were 2 examples of how the math actually works out for these. And again, these were just examples of how we had to do each binomial probability calculation individually with the same number of trials, the same probability of success, and the same probability of failure, but then also our successes and failures, those actual numbers changing, and we had to add these probabilities up. So it was the same idea for both of these examples. And now I just want to go over the different types of wording we could see for a question like this. So I have brought back the Thanos example, where in the last video we found the probability that exactly 2 of the 7 heroes on Titan survived the snap, if the actual probability of any one person being disintegrated was 1/2 or 50%. So now I want to go over the wording that we could see. If we see exactly 2, or just 2 with no qualifiers, then we just have one calculation to do and we're good. That's what the entire last video was about. But there are 6 other ways that these could be worded. The first 2 I'll go over are the ones we went over in the video. At least 3. At least means we start at 3 and go up from there. So at least 3 meant it could be 3, 4, 5, 6, or 7, and we'd be okay. Next one that we talked about in a video was less than. So if it was less than 4, that meant that we couldn't include 4, but we could go down from there. So it could be 3, 2, 1, or 0. Now each of these, the at least and less than, have a twin that tells us to go in the other direction. So if we saw at most 5 of the 7 heroes survived, that means we could start at 5 and go down from there. So the probability that at most 5 heroes survive, we could have 5, 4, 3, 2, 1, or 0, and that would be okay. And then less than has its opposite as well. More than 1. So the probability that more than 1 survive is probably what you were guessing. It can't be 1, but it can be anything greater than that. So 2 heroes could die, 3 could die, 4, 5, 6, or 7, and we'd be okay. Now the last 2 are actually kind of tricky. So I'll do both of them at the same time. You could see this word between. And you could see something like between 2 and 5 of the 7 heroes could survive. Now, there's a word that if you see it, you'll know to do one of these possibilities, but if you don't see it, it's kind of up in the air. If you see the word inclusive, that means that you include 2 and 5 in this range of probabilities that you're trying to find. If you don't, chances are it's going to be the numbers that just fall actually between those, not actually counting them. So if it's between 2 and 5 without saying inclusive, it was just either 3 heroes or 4 heroes. But there could be some book or some problem or test or something like that that either is unclear or tries to trick you, and they could say between 2 and 5 without the word inclusive, but still expect you to find the inclusive probability. So I would ask your teacher, I would look in the book that you're using, but still watch out for the word inclusive or anything that would indicate that you're supposed to include the 2 numbers that come after the word between in your problem. So that is it for probability, if you've been keeping up with all of these. If you have, congratulations. If not, I hope you at least enjoyed this one and that it was helpful. But anyway, if you're my student, as always, good luck on your assignment, and as always, if you're not my student, good luck on whatever work you have to do for this.